Okay, so let's go up to this last paragraph, and that's where we're going to start today. So it says, as Gregor Mendel, so he's a name you're going to want to remember, as Gregor Mendel discovered, each of your traits has two genes. One gene given from your mom, one gene given from your dad. Some genes and traits are what we call dominant, and others are called recessive. Those are two really important words, dominant and recessive. Okay? If I say the word dominant, what does that usually make you think of? If a person is dominant or an animal is more dominant than another one, what does that usually make you think? Riley?
It basically means like he's better actually than something, or he's better, like he's a legend.
You're getting close. You're getting really close. Logan?
That they're like, that they are, the,
Can I help?
yeah. No. You cannot help. Yeah.
So dominant is the stronger gene. If an animal is dominant over another animal, that means they are much stronger, right? Someone who dominates a sport, right? They are so strong in that sport that they kind of cover over everybody else, right? Okay, that's dominant. So if it's either dominant or recessive, then recessive probably means weaker. Okay? Dominant, stronger, recessive, weaker. Let's keep reading and see if that matches up. If a dominant gene is passed down, you will have that trait over the recessive. Recessive traits only show up in a person if both parents pass on a recessive gene. I know this sounds confusing, so hang with me here for just a minute and I'll explain. Okay? For example, brown hair is dominant over blonde. If a father has brown hair and two brown hair genes, because remember each trait has two genes, okay? So if he has brown hair and two brown hair genes, this is called homozygous, we're going to come back to that, he will always pass a brown hair gene to his children. Okay? A father with brown hair could have one brown hair gene and one blonde hair gene. This is called heterozygous because it's two different ones. However, the brown hair shows up because brown is dominant over blonde.
I highlighted that.
Okay? I know that sounds confusing, and we're going to break all this down, okay? The only way an individual can have blonde hair is if both of their genes for hair color are blonde or recessive. It is possible for two brown-haired parents to have a blonde child. Okay, can I show you how this works? This is the part that's going to blow your mind. I'm going to put that off to the side and come back to my little square here.
Both my parents have black hair.
So let me show you how this works, because this actually worked out in my family.
Me too.
Okay? So my dad has brown hair. Always has. Okay? Now it said that brown hair is dominant over blonde, right? So I'm going to represent brown hair with a capital B, right? Because it's dominant, it's stronger, it's bigger. Okay, brown hair. I'm going to represent blonde hair with a little b, because it's recessive. Would you agree? It's little. It's not as strong. Okay? So my dad has brown hair. My mom has blonde hair. Naturally. Okay? Now the only way that this turned out to be blonde in me when I was a baby, my hair was white blonde as a little girl. I still have a spot of white blonde hair in the back of my head. It grows that way. It never changed. It never got darker. It stayed really light. Okay? You can see it if I do my hair a certain way. It stands out. You can totally see it. The only way that this happened, that I happened to get the blonde hair. Let me show you. Every trait has 2 genes, right?
Yeah.
So my mom, in order to have blonde hair, she would have had to have had a blonde hair gene from her mom and a blonde hair gene from her dad. That's the only way she can show up blonde, right? Because the passage said the only way you can see that is if you have 2 recessive traits. Okay? My dad had brown hair. Now, he could have been a brown hair from his mom, a brown hair from his dad, or he could have been a brown hair from mom and a blonde from dad. It wouldn't matter because what's going to show up? The dominant, right? The big one is what's going to actually show up in a person, the big letter. So even if this is my dad's gene combination, which it was, okay, it will show up that he has brown hair. Now, the only way that I know that this has to be his gene combination, you ready to see this? Okay, is this really cool little chart, and it's called a Punnett square. It's a weird word,
We can't see the chart.
okay? Now, this chart you can do with any trait known to man. Okay, let's say blonde and brown hair. So if my dad had brown hair and he had 2 dominant genes, let's say, and my mom had blonde hair, she had to have recessives to get that. Then when I put these together, these show all the possibilities for their children. So right here, I have a big B and a little b. So that possibility, this child would have what color hair? Brown hair, because there's a big B. Anytime there's a big B, that wins. Right here, there would be a big and a little. So this child would have brown hair again. Down here, big B, little b. So they would have brown hair again. And then right here, big and little. 3:05. It's an hour, a whole hour. Still 4. Okay, so in this combination, if this is what my dad had, is there any way I would end up with blonde hair? No. This means all of their children would have to have brown hair. It's not possible. Yet here I am. So that means that my dad had to have had somewhere from his mom or his dad a small b, a blonde gene. Because, watch this. Here's the chances for his kids. This chance would be brown hair because there's a big B. Oh, look at that. 2 little B's. That could have been me. Let's look over here. Big B, little b, that's a brown hair. And, oh, look at that.
Wait, how many siblings do you
So my mom and dad, each time they had kids, had a 50-50 shot at getting a blonde-haired child. It just so happens my brother had brown hair. I had blonde hair. Do you see how that works? So in this situation, my parents would have, it'd be a toss-up. Maybe they'd get a brown-haired kid, maybe they'd get a blonde-haired kid.
There was a back and forth.
Now, You want to know what red hair is?
Yeah.
Red hair is a double recessive gene, which means it's only two smalls. So let's say my parents, one of them had red hair. Okay, what would be the chances that I would have red hair?
50-50.
75.
75.
Brownish. Not really a good chance. Well, I mean, 50. 48.
It'd be 50-50 again, right? 2 out of 4 would have brown hair. 2 out of 2, or 2 out of 4 would have red hair. It'd be a 50-50 chance.
None of his parents had red.
Great question. None of Calvin's parents had red hair. Watch this. What if I did this? This parent would have brown hair, right? Because there's a big B. This parent would also have brown hair because there's a big B. But when I put them together to see what their kids could have, this is what it would look like. See it? This one would be a BR. There's the redhead. So there's only a 1 in 4 shot that a kid would have red hair. It happened in Calvin's family. That's why the rest of his siblings did not. Because the chances are high that there would not be red hair in the family.
But there was. But he got it.
You see, he got it. He was this little oddball right here. Now, let's say that Calvin marries someone else with red hair. Now, the only way that could happen would be this,
Go away from that.
okay? So if this was the case, if Calvin had red hair and his wife had red hair, what's the chance of their children having red hair?
100.
100%, they'd have to have red hair.
What if they have black hair?
No other way to do it.
Well, if Meg and Calvin, they still had a chance for red.
Remember, even if it turns out like this,
It's still red hair.
then you're back to 50-50.
Black.
Does that sort of make sense? It's just kind of interesting. So can I tell you some other traits that work this way? Okay, there's something, your ears. Feel your ears.
Those sound like
It's hot.
Okay? Your ears are